Yeah, hello everyone. Today I wish to discuss about generative models and how they're changing the paradigm of machine learning and why the world is getting crazy about generative models. So generative models are actually some piece of models or like a particular class of model which comes under the realm of unsupervised learning. And if you have been doing machine learning for a few months or even I don't know for a few weeks, let's say, then you would know that the expansion machine learning is more of like towards the unsupervised learning paradigm rather than the supervised learning paradigm, and due to the obvious reasons of like the data set find not able to find a good labeled data set as in to train your supervised model. So what people do is first train their unsupervised model and then try and fine tune it or align it towards getting a better prediction results on which they would have gotten from their parent supervised model. So again, unsupervised means training without labels. So, and that's what generative model would do, right? So what do you want to do? You have certain data. I mean, data as in without any labels, let's say. You have certain images. You don't know about the images. I mean, they may be images of like numbers, which is like a very popular data set called MNIST. Images of celebrity faces, which is again a very popular data set called celeb whatever, celeb A and then HQ and things like that, or derivative of that data set. You may have you may have data set of like voices of certain celebrity or like even musical notes of a piano, let's say, and you want to generate similar things, that is to generate images from images, to generate piano notes from piano notes, to generate I don't know text from text, let's say, which is also a very popular model these days. uh, so what you need is a thing called generative model. So generative as in the word sense, generating things, right? So if you just expand the space of generative models, there can be like a wide variety of models. And I mean, to just classify these models into some like with some boundary among them, then you can maybe coin in the term of like some models which are like explicit in generation, some models which are like implicit in generations. So what does explicit and implicit mean? So explicit means explicitly it's doing something for generation, which is, I mean, explicitly, I mean, what would it be? What would it do? So as stated by me like just few minutes ago, it wishes to learn the probability distribution of the parent data or the training data, right? So if, as per se, you can just say that, okay, learn the probability distribution of the parent data, which is like, let's say px naught. Again, so px naught, so since you're learning something, so you want to have a learning parameters as well, right? So let's say p theta of x naught or px naught, I mean p of theta, and this is the theta parameter which you want to learn in order to just learn the intricacies of the initial distribution. The very naive, not actually naive, but the most fundamental generative model in this space is actually a Gaussian mixture model, um, which is, I mean, yeah, which is a parametric model actually, and it's very intuitive that whatever distribution of data you have, you just wanna fit in Gaussians. It can be unimodal, it can be bimodal, it can be any modal. But what you want to do is to like first assume a Gaussian and then kind of like see how see how the data is getting not fitting your assumed Gaussian, then shifting your Gaussian, then again fitting your data with that shifted Gaussian, and then seeing whether it's good, bad, not good, not bad. So in literal sense, what I just said was something like finding the posterior by assuming a first a prior calculating the likelihood, and then finding the posterior, and then updating your posterior. So again, when you talk in terms of posterior, likelihood, and priors, things become complicated. That's why I was not mentioning it. So I mean, just mentioning it, I mean, just by speaking it is difficult, obviously. I mean, if you have to write it. So if I was writing it, then I would have definitely loved to explain more about this. But yeah, so just think in terms of, think in this term, like there is a data set, you assume a Gaussian or a multivariate Gaussian, like two humps in the Gaussian, and obviously multivariate means multi-dimensional, so that's fine. So a bimodal multivariate Gaussian, and you then fit the data, you then check the data whether it belongs to that Gaussian or not. If it doesn't, then you shift the Gaussian in certain direction. That shifting is actually done through a very sophisticated algorithm, which is like one of the best algorithms, which actually forms the basis of machine learning. It's called the expectation minimization or maximization algorithm. Min-max is just two opposite terms. So, but the thing is, you have to minimize the expectation, isn't it? Or maximize the expectation. I am just a bit confused with that. Let me think. The expectation of a data is actually the expected. Okay, so you want to maximize the expectation, obviously. So it's expectation maximization algorithm. Okay, good. Yeah, so that is what it is, to shift the Gaussian in a certain direction in which your expectation is maximized, and then again do this step repetitively until you converge to some point. So cutting it short, these are like fundamentals of diffusion, fundamentals of generative model. Then there are like classes of generative model, which I was mentioning previously, like implicit, explicit, auto-regressive, and things like that. All of these do the same thing in different ways. You may have heard of a very popular explicit model, which is GANs. GAN is not an explicit model. It doesn't, because why is it not an explicit model? Because it does not explicitly model the probability distribution, or does not explicitly tries to learn the probability distribution of the data. What it does a min-max game actually, which is like there will be two players in the game, and one will be saying that okay, I have an image of something. The other one will be detecting something, that whether that image is true or false, like whether it belongs to that real data set or not. And according to that, the person will tweak in something, that, or maybe he'll draw digits more in a different way. Like let's say it's a game where there is this person who knows the language in which a certain book is written, and there's this person who doesn't know the language in which this certain book is written. So what this person will try? This person will try and tweak, and then try and maybe guess first. So let's say he writes something a letter in let's say Greek or something, and this person would say no, this is not true, because he knows the original data, right? So this person then tweaks something, and then the detector again detects like, okay, this is right, this is wrong, things like that. So this person at some point of time, after some tweaking, this person would be able to fool this person that okay, he knows which language is there. I mean, not fool in like which language is there, but to fool him like what is written over there. He knows, like he has, to just fool him that he has read this thing, but he hasn't actually. He was just playing a game, and he's kind of won the game. So this is what, how many minutes? So it's 9:33 already. Okay, good. So, and then there will be different models like you must have heard about autoregressive models, which are like natural language processing models, and you may have heard about diffusion models, which are actually explicit models, and they're also like Markovnikov, the graphical models. So this was my brief introduction to generative models. I know it was bad, but it was my first try. It was first time speaking in front of a camera and then explaining stuff. So I don't know. Maybe I'll put this thing in recording. Maybe I won't. Let's see. Let's see how it goes. Thank you.